Hi, my name is Noah Emanuel. Here we have two elements. One is calcium and one is sulfur. If you look on the periodic table, you'll see that sulfur is in group 16, meaning it holds 6 valence electrons. So when you look at the orange balls that represent how many valence electrons I have, those represent the valence electrons. In order to enter stability castle, you need to have 8 valence electrons. So when you see sulfur try to enter stability castle, which is me, he's going to be denied. But sulfur really wants to become stable. He'll do anything to get it. So he's going to head over to calcium and punk calcium out of his 2 valence electrons that it needs to become stable. But you know calcium, he's not a punk. So he's going to try and give some resistance. As you can see from the look on DK's face, he's clearly distraught. Why does calcium lose this fight, you might ask? Well, sulfur has this thing called high electronegativity, which is an atom's ability to attract shared electrons in a chemical bond. Fluorine has the highest electronegativity out of all the atoms, making it the queen bee of electronegativity. And the closer you are to her, well, the higher electronegativity you have. And sulfur is right there next to her, meaning he's better at taking electrons than calcium. But in fact, metals actually don't want to take electrons in a chemical bond, and would rather just give them up. And as you can see, once sulfur takes calcium's 2 electrons and combines it with its own 6 electrons, it now has 8 valence electrons and is allowed into stability castle. But wait, what about calcium? Well, in this type of chemical bond, when the sulfur took the calcium's outer shell of 2 valence electrons, the calcium actually fell back onto its inner shell of 8 valence electrons, which makes it a stable atom, allowing it to enter stability castle. Well, wait a minute. What kind of bond is this? Well, it's an ionic bond. You see, ionic bonds occur when the number of valence electrons in a metal are fully transferred to a non-metal. No sharing whatsoever, only taking. And that's definitely the case for a bond between sulfur and calcium, making this an ionic bond. Thanks for watching. Noah Emanuel, signing off.